Awesome. So welcome everyone to the Building Hydraulic Models workshop presented by RiSWP. Feel free to introduce yourselves in the chat. We're really excited to see some old faces in the audience, lots of new faces as well. So welcome to everyone. This event is being hosted by SWAN, the Smart Water Networks Forum, the leading global hub for digital solutions in the smart water and wastewater sectors, and by the Rising Smart Water Professionals, RiSWP's Sorry about that. RiSWP's young professional community. Oh, there we go. Just a couple of exciting events we have coming up before we get to the main event tonight. We'd love for all of you to join us at our upcoming mentor series on October 19th, featuring this really amazing utility innovation panel, featuring 4 stars from 4 global utilities. It's going to be a super interesting conversation. Make sure you join us. And for our main event for tonight, I'd like to introduce our facilitator for the evening or afternoon or morning, wherever you are in the world. Please join me in welcoming our facilitator, Idel Montalvo PhD. Idel is an expert in designing and developing software solutions for solving hydraulic engineering problems. He has vast experience working with multi-objective evolutionary algorithms and data analytics with applications in water distribution systems, with advanced skills for water network modeling, more than 5 years of teaching experience combined with more than 20 years writing software for the water industry. Idel is passionate about sharing his knowledge and equipping the next generation of problem solvers. So if everyone can just give me a round of applause, I'm going to hand over the floor to Idel. Thank you so much for joining us tonight.
Hi, so I will share my screen here. Check. Yes, perfectly. I can share my screen with you. Well, today we are going to talk about an interesting topic from my point of view. Most of the utilities I know are going on the digitalization, and most of them are dealing with creating a hydraulic model to find the right software that they need. And today we are going to be specifically talking about how to create hydraulic network models online with a tool that we have been building in our company, and how to introduce you to use computer programming without being a software engineer, but basic computer knowledge or the skills just to interact with the hydraulic network model in the time that you are building it. So we are going to be introducing, I would say, for the first time, a way to create hydraulic models in a collaborative way. So different people could be introducing data into the hydraulic model, could be adding changing into the hydraulic models. And it is a practical thing from my point of view, since when you think about a city, and people start creating a model in there, normally you have one person in one computer introducing some data, then that person should be giving the data to someone else in another computer, sharing it with a stick. And we are going to be showing today a different way to do it, a different approach, a relative new approach to do it. And I hope we are going to be enjoying it. As a programming tool, we are going to be using Excel, macros in Excel. Excel is a tool that probably you have in every company. It's very useful to have it. That's why we selected that. Some people prefer Python, some people prefer some other language, C++. At the end of the day, the language doesn't matter too much as long as you have clear the concept of web API, how to interact with elements, and the basic element of computer programming. So I will be doing a very small introduction of our company. We are located in Karlsruhe. We have a small team that combines developing, software development, and engineering. So that is the reason why our name is Ingeniousware. We're trying to make the bridge between what is software engineering and the hydraulic engineering part, or the engineering of other domains, in order to develop software, but also to give consulting from the hydraulic point of view, and also the support of bringing online courses to the people that are interested on these topics. Okay. So I will present you, first of all, I will go directly to the point. The platform we are using, that we have been developing, of course, the platform we have for creating hydraulic network models online. First of all, you're going to realize there is nothing to install in the computer. You just need to open the browser, and on top of the browser, we can start creating a hydraulic network model. At this time, I know there are several solutions, very good solutions out there in the market already working from the browser. But most of them, at least as far as I know, most of them require you to upload a hydraulic network model. When the hydraulic network model is uploaded into the system, they can run simulation. They show you amazing charts and graphic and the result of the calculation. It is great, but basically you have to upload the model first, and then you interact with the model later. Here we started on the part of creating the model by itself. Then we are going to see that we can run a simulation in there, but basically the first step is to create the model, and this platform was originally developed to create the hydraulic model at first. As the platform is online, fully online and based on the browser, you can open it from anywhere. But not only that, several people could be opening that platform at the same time. Once you have a project, once you create a scenario of a hydraulic network model, you can easily share it with some of your colleagues, with some of the people working with you. And once you share it, you are able to open the same scenario, the same project, at the same time, and to work at the same time in this in the project you have to be solving. I love to say it is like Google Docs, but for hydraulic network models. Why I love to say that? Because we were really inspired in Google Docs. It was amazing the first time we discovered we were able to edit a document, several people at the same time. Since that moment, we have been using it in every meeting that we do. We create a report for the meeting, and we add the input, each of us at the same time in that document. And the same idea we try to develop here in the software, so that we create a hydraulic network model. Each of us interact with the model, add pipes, change demand, whatever, run simulation, and the simulation results are available for everybody. And that is the idea behind. Okay, so two important things: multi-user edition of the hydraulic network model, and the possibility to open the model and create the model on the fly, no matter where you are, as long as you have a browser connected to internet. But let's check directly the platform. I will have it here, so I will move it to the picture, to the screen, and sharing. That is the way the platform looks like. Well, first, when you go there, I think we were sharing already the link, but just in case, you just need to write open.watering.online in your browser, and just and if you're going to be probably needing a username and a password, there was some username and password already shared with you. I think if not, you can just write it in the chat, and I think we can add this information in the chat. It was created just for this webinar so that you could have a better input or a better possibility to follow what I'm going to be talking about here. So I will log in. I will use actually one of the accounts that we were sharing. So I will copy the account here. And I will enter my back account. We have some restriction, the account, but it's going to be enough for the thing that we are going to be doing. First of all, when I open it, when I enter the system, there is one single project already there. It is a project I created in advance, and I was sharing that project with the 3 users that we created for the purpose of this webinar. So it means that if you enter into the system with any of those 3 users, you can enter right now. You are going to have the possibility to see the same I'm doing here on my screen. Okay, so the first project is there. You can click on open. The project will be open. There is a scenario that I had open already by default, but here at the right side, you are going to have the possibility to check how many scenarios we have, all the scenarios we have in there. And I would say, let's go first to the scenario number 1. This is a scenario I created just for testing the model creation. Let's call it that. So I click here on open. And that is in a scenario that is basically empty. There is nothing in there. I will place over here. I will place over here a reservoir. And if you enter into this scenario, you just need to click in this point, and you're going to be directly going to the place where I'm located right now. This town you are looking here that is coming by default. I put it by default in my computer. It's a small town very close to Havana. Normally, people that have been taking courses with me knows it because, oh, now I see that several people, some people are connected. You see this small circle here that was moving here. It is someone else that is connected. Let me check the user. Okay, people have been using the same user several times, but you see here there is someone, I don't know who is it. If each of you have his own user, I'm going to be looking here exactly to the user of the people connected. As we are connecting all of us with the same user, I just see different color, but I don't know exactly who is the person. But I know that is someone else in there. I can see the mouse moving, but it's basically the idea of editing online. Not only that we can make changes all together, but I can see where the other person are located. And I was mentioning this small town is something that I normally use in all my demos because it's the place where I was born. It is in Cuba, small town in Cuba, very close to Havana, about 60,000 people in there. So I was born in there. That's why I know it very well. My house, or the house of my parents, still over here. That's why I use it normally in my demos. Well, I introduce a reservoir here, and to introduce elements of the model is not so different to do it, or not so different compared to EPNet or any other software. You just click here on the element you want to use, a reservoir, a tank, and the man node, a pipe, and you just go to the map and click on top of the map. So if I want to put a tank in here, I just come here, select the tank, I come to the place where I want to put the tank, click on there, and that is a tank. That is a particularity regarding pipes. I'm comparing to what I used to do when I was working with EPNet. When I used to work with EPNet, or whenever I work with EPNet, you need to put nodes first, and then once the node is existing, you can join two nodes with a pipe. Here, that principle will be also working, but that is something that could make life easier. And it is like I would select pipe here. So now I can add pipes. I click in this node. The node is selected. I can move my mouse and you can see that there is a pipe about to be inserted. It is just waiting for the second node to be drawn. The first node is the reservoir, already it's fine. And the second node, if I make a click here, for example, click here, and what is happening is that a new node has been inserted automatically, even if there was not any node in there in advance. So if there is no node in the place when I'm clicking, a new node will be inserted. If I click on top of a node that is already existing in my model, then the pipe will be connected to it. Otherwise, a new node will be created, and automatically the pipe I was drawing will be connected to that new node, and from that new node will be extended the following pipe. So I will draw something very fast here. So I will be just drawing a line through this street and getting connected to the tank on the other side, like this. And I got connected here. So from the other people that were connected, I don't know where they are. There is one person here. It's not a problem. Here, you feel free to do whatever you want here. You can select something in here, a pipe, a tank, or whatever, and try to add it into the model. And then theoretically, we all are going to see that something has been changed or added here. So if I open a different computer, I have a different one here, and I add something from this side, then it will be shown automatically in this part here. So if someone is connected, feel free to select something from here from the top and add it in this area where we are located right now. And then we are going to see it. So here we go. There is someone probably doing something here in there. I can see it. Let's hope it will be adding something, and we are going to be looking at it anyway. Oh well, we can wait. One important thing is that sometimes it is better to have a view of different elements we have in the model, but a table view, a tabular view of the element that we have. And that's why we have here like a way to show in a table format all the elements that we have been inserting in there. So there are some names given by default. to every element that we insert. Latitude and longitude are automatically taken from the map. Here you can make an addition of any element, change the description, change the coordinates, change the base demand, the demand pattern, everything can be edited here. But from a table perspective, the same will happen to pipes. Some values are going to be given by default to all pipes. And here, of course, you can edit any of those pipes or any of the elements you put in the model. And additional, now there is someone that added a tank over here. Great. And additionally here, if I click on select, I can click on this element here, and I can see the properties of the left side. I can click on it in a pipe. I see the properties given to that pipe. And of course, I can change here. I can edit here the properties, whatever the length, but I can change the diameter. Whatever property I consider can be changed from that side. Once you create the hydraulic model, so here we are talking about that we are located in this part of the system. Once we create the hydraulic network model, then we are ready for run hydraulic network analysis after that. But the first step is to create that model. In case you have a hydraulic network model already in EPNet or in EPNet format IMP file from EPNet, either if you export it from other system or you create an EPNet, you can here upload the file. Files, IO, input, output. You can here upload it, or it was not activated for the user. The function is not accessible for the subscription license. I forget to activate it. But anyway, if someone wants to test it with a real model already from having an IMP file, just get in contact with me and I can give you a free account for 2 weeks so that you can test all that part. But basically, you can upload an existing model. And once you upload the model, you can do change on top of that model. And as I will be showing you later, there are also possibilities where you can edit that model automatically from Excel. Imagine that you have a list of elements in Excel, and those elements are representing nodes, for example, in your network, and you know the demands based on the information you have in Excel. There are ways to automatically from Excel update the model that you have here online, and we are going to be getting into that part later. Okay, so creating the model is what I was trying to show you here in the first step. The scenarios or the project, you can share it anyway with whatever user. Just need to add here the user you want to share, and then you're going to be editing it with everybody. The analysis, I will open second scenario that I prepared with a little simple calculation. So here is a very small examples I created. And then we have the analysis part. In the analysis part, we can run a simulation in there, and the simulation results are going to be stored in the database behind this software. So running a simulation, I will run a new one here, is just click on analysis, new execution. A new execution is started. And when that execution is started, well, it is first requested. You can see here at the top right, you're going to be looking first looking at the word requested first, then calculating. And once the calculation has been finished, it will be showing you these controls that are the default control for extended period simulation. Here, it was just a simple simulation with a very simple network, just to show you, to illustrate how things could be going. And the pressure calculated, when you click on elements, in nodes, for example, you can see the pressure that was calculated and given to the model. Basically, what is happening here is that we had the model, we created a request for the network analysis. That request is sent to a server somewhere in the cloud. The server calculates the hydraulic network analysis and send you back the results to your computer, to the browser, where you can look at it. There are other software that run the hydraulic analysis on the browser, directly on top of the browser. We are not doing that. We are running the calculation in the background. In this case, we are able to run several thousands of calculations in the background, in the server, at the same time. For doing that, we need to modify a lot what we had from the EPNet toolkit. So we practically rewrote that EPNet toolkit using a different language that was easier to hold in the cloud. And that's why we keep on we kept the idea of calculating in the server based on that new toolkit that we had for running the calculations in there. And that toolkit is exactly the same that you would be using if you are in Excel and want to run a calculation from Excel using our servers. Okay, so basically we can click on any element, and I'm going to see the pressure that was estimated and the demand. In this case, demand is 0. Here the demand was 5 liters per second. The demand cover was 5. Demand use was 5 liters per second. It is a simple calculation. If I click on a pipe, I'm going to see the flow. In this case, that's what's happening here, the head loss. So basically the same results I would be looking at if I had run this element or this model in EPNet. The only difference is that you are running it totally online with a separation between the front end, what you have in the model, and where the calculations are happening. So the model right now is in the computer, and the calculation right now is happening in a different server and sending the result back to your computer. That is from the programming perspective, the way it is working in the system. Of course, there is an execution management too, where you can go and check all the execution that have been completed or have been requested for the model you have been doing. So here you can come to the execution management and get back to any execution you had previously for the same scenario and the same place. So all execution are normally saved, stored, and you can have access to all those results at any time. Okay, so that is the part of the analysis. Basically, what I wanted to show you from the point of view of the functionality. I will go back to my PowerPoint in a minute. We were talking about the creation very fast. The creation of the hydraulic network models. You have the username and a password that you can enter on your own and test the creation of a single network model. I will show you later an example that you can use that we are going to be giving it to you for free as part of the webinar, so that you can use to test yourself if you are able to create a hydraulic model here, or if you are going to be doing the first step on hydraulic model creation. The online simulation is what I was just showing you before. I forgot to mention that it is possible to put colors depending on the results that you are getting from your simulation. Exactly the same way that you do it in EPNet, but with the possibility to add more conditions to set up the colors you want to give. For example, you can say not only that you want to put in red the nodes having a pressure under 10 meters of pressure, for example. You can also say, I want to see in red all the nodes that have a pressure under 10 meters, but additionally, water demands bigger than 15 liters per second. So that would be, anyway, a very problematic node. Low pressure, high demand, that is a problem in there, by sure. And then you can make that configuration in the moment where you want to decide what color to give or what size to give to any of the elements of your on your network. Okay. I will go to another point before opening my Excel and showing you how to interact with the elements that we have online. The third element I love to talk about whenever we think about modeling is the part of monitoring. Why the part of monitoring? People start building a hydraulic network model, and the big question is always, why do I do this big effort? Why do I need a hydraulic network model for? And you can use it for many decision making, that is true. But one of the, let's say, application that I see really important and something that is really useful from my point of view is the possibility to use the hydraulic model with online calculation just to have an estimation of what should be happening theoretically in my system and what is happening in reality in that system. I use the hydraulic network model just to make the calculation. So I take measurement from the field, by sure. I take measurement from the field, update the hydraulic network model based on those measurements, depending on what I can get from the field. For example, water level in a tank. I have a measurement of the water level in the tank, and I can get that measurement from the field, from a sensor, and update my hydraulic model with that information. So I have the same tank in my model. I put in that tank what is the level I'm getting from the sensor, as an example. And after that, I can run my model, and my model will be closer to the reality in this case, because I have been updating the model with that information. I could even do like a mini calibration in between two measurements that I'm getting from the field. It is possible to do it. Just the idea is to get as closer as possible to the reality based on the information I'm getting from the field. But once I have the model updated with that information, what should be happening? Imagine that you receive some measurements at 8 a.m. You update your model with those measurements, and you calculate, you make an estimation with your model of what is going to be happening half an hour later, let's say at 8:30. It's fine. You have an estimation of what should be happening half an hour later. Half an hour later, you're going to receive new measurements also from the field. And the same thing, the first thing that you're going to do with those measurements is just to compare, okay, what was the expectation your model had for 8:30, and what was the reality you got from your field measurement. And based on the difference of those values, you're going to be in a better position to say, okay, everything is working fine, or maybe I have an anomaly here because of the difference of what is my expectation and what I'm getting from the reality. Of course, you are not going to have a perfect match all the time. Sometimes you're going to be a little bit bigger, a little bit like this, but what should not happen is that on the time, you are going to be getting a bigger difference and a bigger jump in the time. It's going to be probably a representation of what is that an anomaly was happening, or a sign that an anomaly was happening there. If you see that your model is going to be getting deviated suddenly from the reality that you are reading from your sensor. And this part of monitoring of anomaly and notification, anomaly detection, it is something that, of course, we have been building some functionalities on it in our system, but additionally, it is something that if you have some basic knowledge about computer programming, it is something that you can also develop from your side based on your experience as an operator, or based on your experience as consultant, with tools like Excel or Python, or some additional libraries that you could be using. And then I will get very fast to Excel, just in order to give you an idea of how does it work, this connection I'm mentioning you with the programming part. We are going to get back to the platform later. Okay, so I will show you an Excel example here. And I don't know if some of you have experience with macros in Excel. I hope yes, but if not, you can write it in the chat. I forgot to say at the very beginning that feel free to write something or to interrupt me and make a question. If someone have a question, I don't know, Moyo, if someone write in the chat and have a question, I can just get to it in real time if someone want to know anything, okay? Otherwise, if I don't hear anything, I continue showing here the idea. First, I will take the platform, as you see, this is the platform for the normal user when you work in it, but there is another link, same platform, but from the back end, that is called dev.watering.online. Not open, but dev, from development, dev.watering.online. Here it is presented a standard of what is called the documentation of a web API. This web API gives you access to all the functionalities that you are going to find in this platform, but from a programming perspective. Here you work as a user. Here you click yourself, add a node, you put a node in the place you want. Everything is, let's say, user-based. Everything is like based on the user interaction with the system directly. Here, you can get the same interaction with any functionality of the platform, but from the programming point of view. What does it mean? You have your own system, and your system have measurement, the field measurement, pressure measurement, flow measurement, whatever measurement you have your SCADA system, you have your own control in your company, and you just want to use our simulation for running calculation in there, getting the result, and just adding our result to the tools that you have built. Is perfectly fine to do something like this. You just need to connect to our system through the web API, send the information that our system requires to run a simulation or to run whatever you need to run, wait for the results, read the results, and incorporate those results into your system. Here we are going to be doing an example of how to read, first how to log in from the programming perspective, how to read what project you have available, what projects are accessible for your user, what scenarios can you read, and based on that, what elements can you read from the model that you have. Okay, so that is the web API. It is what is going to be used to interact with the model. I will start with the very first sample from the web API, and a sample where we don't need to have any login, any user. Here, there is a long list of functionalities. Okay, each functionality is connected to one element of the platform that we have. Of course, when you start programming, you need to check what do I need, what do I want to do, and what do I need to do that I want to do. I'm going to show, for example, regarding the authorization and management, what is the platform about, some information about the platform, who built it, for example, and we can get that information using that functionality here. So here in this documentation, you can try directly without any programming or without any additional tool. You can try additionally what is going to be happening if you call to that functionality. I will click here and try it out. And then the system is ready to accept a call from the programming perspective to the platform, and we are going to be getting the response directly here. Let's check how does it work. Here you need to write the version of the platform that you want to access, the version of the web API that you want to access. You just write the number one. There is only one version until now. If there is another version in the future, you are going to keep on working with the version one, the same that you have been using for building your system. If we make changes, we are going to be creating version 1.1, and it means that we can add functionalities without disturbing what you were already using before. That's why the idea of adding version to the web API. But if I write one here and I run execute, the system make a request to the server in the back end, and you get here some results, and the results are looking like this. It is called JSON format. It's a very well-known format for software developers. It is, I would say, a standard today for communicating information when you access a web API, and it's used in a lot of systems. So web API is not something new. It is something used in different systems. You use service from Google, you're going to be by sure using web API and this format in JSON format. That is what you get from the server as a response. This response is just informing you, okay, who did the system, what is the name, the description, something that we build there, just to check how things are working. But the same idea could be used to read, for example, give me all the nodes that I have in my model. And we are going to get to that point very fast. That is the first idea. Of course, if I go now to the part where I want to get all the nodes, and I get all the nodes from my system, then the first question I will be doing is how the system knows what nodes I wanted, because I could have 3 projects. How the system knows what is the project I want, and how the system knows that that is my project, how the system can identify me. And that is the first element where we need to get an authorization, where we need to get a login. Here is where you can get a login. A login, for those people that haven't been working with programming before, is nothing else like you have a username, you have a password, and you receive like a key, a token from the server in this case, and you use that token every time you want something from that server. It's just a very long string. You have to send it every time, and that is a string that the server used to identify who you are and what are the rights you have in that system. That is what is happening when we try here that application. I will say try it out. I will add here the number of the version. He's expecting here to have the username and the password. I'm going to use the username and the password that we share with everybody here. So I will not write my username and my password, otherwise it will be a security compromise. But I will use the the account we create is a limited account, so it's no problem. We create that account. And here I will say execute. And here we go. The execution was fine, no error, nothing. You see here the result of the execution. And this token here, this long string, is what is a token, what is going to be used in the future to show the computer who you are and how to identify you. So I copy this, go here to authorize, copy the value of that token, click on authorize, and I close it. And now the system has been doing like a login. So now I'm authorized, now I have a token that identifies who am I into the system. And after that, I can call functionalities from here and the system will know who am I, okay? And that is now everything from this interface here without any additional tool where you can write or where you can use the functionality from a programming perspective. So I will go and check what project do I have. Project water network. There are basically 4 actions that you can do when you are working with a web API. With this web API or with whatever web API. You can make a GET request where you basically read information from an external system using that web API. You can make a POST request where you basically put information, new information, you upload information into that system, you send information to the system. So first the GET, you get, then the POST, you send something. You have the PUT where you want to modify something that is already in the system, just to make an update of a water demand, for example. It's just a put, and you have a delete where you can just remove something that is on the system. Okay, a get. I will use the same. Let's say I will say try it out. I have to click here and try it out first. I will write the version 1. I'm going to run execute. And basically, it should make a get request of all the project I have. And here you have the project. The project is called Swamp Webinar. The description was demo 1. Here was the creation time. Here we got the information of the project we have already from the programming perspective. What is the importance in here? Okay, this server key ID. That is very important. Why it is very important? Because when we are here as a user, we don't care about the key. The system handled that for us in the programming part. When we are here, that we need to program explicitly say what we want, and we want to read nodes from a project, for example, we need to have the server key ID of that project, this element here. I will read the nodes I have in the project, and then I will show you how to do it from Excel directly. I will here, my nodes, okay. Nodes, demand nodes. Here are the demand nodes. We made like this. Okay, that is something first. So I was reading the project. The project was giving me the project key ID. I was mentioning it was important to know this project key ID. That was for the project. I will read it here, but I forgot something. The scenarios. So with the project key ID, I just can know the scenarios from my model. So I will write here scenario water network, and I need to check first what scenario I will have available. I will see, try it out. Project key ID. I will copy the project key ID. I will write the version of the API I want to know. I run execute. And here I have the list of my scenarios. We have 3 scenarios, 1, 2, and 3. I will get again the server key ID of scenario 1. And that is what I'm going to need to go to get the nodes of that scenario. So here I'm on the demand node. I will say try it out. It's expecting to give me, she's expecting me to give the scenario key ID. I will give it here. I will give the version number. Assume you don't need it from the programming perspective because that is not going to be any visualization. And I will click here on execute. When I click here, you get here the list of all the nodes that have been created for that scenario. This is great. This is great because here you can evaluate practically anything before going into the real programming. But in the practice, here is just for evaluating this web API, where it makes sense, where you can start to create your own things. I would say, here we go, in Excel. And once you have here in Excel, I can share this Excel table for people wanting to take a look at it. The first thing that you're going to learn in Excel is how to add a button. I will go to the developer tab here, where I can create macros, and I will say I will add a button here. I will put it in here. I will create a new macro associated with that button, and here we are. This tool here, that is the editor. Oops, my screen is moving. That is the editor for Visual Basic Application, for application VBA. That is the editor that we use for creating your own code associated to a macro in Excel. And here we write something very fast. I will say message box. And I will say a typical example on computer programming, the Hello World example. You are going to find it in every book, a Hello World example. I will change here the name of my button, and I will say here my first button. Okay. I can click this element, and here there is a message box up here. So here is the way you associate. You create a button, you associate it to some code, and you can do some action programmatically in there. Of course, just a message box is not going to be helping much to deal with hydraulic level models. But here, first you need to do a login into the online system where you have your model. Login here, I will use the same account that we got. Let me check where is it. Here it is. I will write the username. I will write check password, accept, and there is a new token coming. This new token was actually the result of what we did before. So the new token, the system was calling the new token. Now the new token is there. I can read the project. I will remove all this. I can read the project associated, read project. I have only one project here, it's one webinar. It's fine for that user. I select it here. I go to the scenarios and I just read the scenarios I have available. There are 3 scenarios. Those are the 3 scenarios I have. I can go to model elements. I will remove everything in here, check. And I can read the elements from my model. Okay, those elements in my model, I think those are the same element I have online, and I will check that. I will go to my online system. That is the scenario. Let me check the scenario 2. Scenario 2, right? I'm already in the scenario 2. I will take one of my nodes and I will add to that node in my description. I will check, I should go to models. I will take this node here and I will add in my description last node. And to that last node, I will add the base amount of 10 liters per second. And theoretically, I made that change. That change is already done in the system. I will just control that I can read that information back in my Excel. So if I go to Excel and I click here in read elements, oh, here I see that in my description, I have a last node appearing. And in my base amount, I have a 10 in there. What does it mean? That if you are creating a model or you have many people creating your model and you want to have an Excel version of all the elements you have in your model, you create this macro, you read the information, and you're going to have an updated version of what you already have online. The other way around, it is also working. If I start changing the set coordinates of my model here, and I upload that information using a macro, you are going to see the change directly into the online system, and that have been updated automatically. Where it is particularly useful, where you have, when you have measurements, you have measurements associated to the model, you have measurement that you are maybe collecting directly from the field, you have measurement that maybe you have been reading it with the data logger, that where you can use it to have a CSV file from your data logger, but it's not connected online. Here, using a macro, using the web API I have been describing you can upload that information from the data logger to your online model, push all the information there, and to have it available in there. So the time is not like too much time in 1 hour to show you how it works with the measurement. I will just be opening a scenario 3, what I call measurements. I will go to monitoring, and I will be showing you monitoring charts. That is a measurement I just created, and I uploaded the measurement from Excel. This measurement was coming, like any measurement coming from a data logger. I had a CSV file with just 5 measurements, and I just uploaded those measurements using a macro for uploading it. And now those measurements are accessible from my system, and I can run comparison between the measurements and the hydraulic level result. And that is the point I was mentioning you before about the monitoring part. At the end of the day, it is important for a water company that you have a single place where you can put all the measurements, no matter the sensor or the technology you have been using for collecting it, okay? And that is possible using the web API and the platform that we are showing you here today. Once you have that, all measurement in one single point, the next thing is you create your model. You have one single model available for your whole company, and then you can start creating whatever you think it made sense for you and for your company in order to make a monitoring comparing the result of the hydraulic level model coming and the measurement you are getting from the field, and that you have been concentrated, all of them in one single place, no matter the technology, no matter the provider, and no matter the type of sensor that you're getting, just using this web API and that system in the background. Okay, you have I'm going to show you one more thing at the end, and it's the control panel. This control panel is not about running modeling, it's about making an abstract view of the result you have from your model and the measurement you are getting from the field. This abstract view, if you go to the model, you're going to see something like this: one main source bringing water to this region here that is called wet sector, and bringing water to this region here that is called industrial sector. It is fine. You have a lot of information in there. You can add every single pipe in the model. It's going to be fine. But for the operator doesn't want to know. He doesn't want to know all the detail. He just wants to go here and take a look. Okay, how much water is leaving my main source? How much water is coming here? How much water is coming here? And just to have an abstract view similar to the view that you normally have in a SCADA. Here you can fully control this view. You can create, make a configuration of that view, add new element to that view, new sector, add that new sector, no matter what you want, and to say, okay, I want to add a new sector connected downstream of this sector west, and just like this, you can connect it. And you can actually add here measurements, no matter from which sensor, that are going to be represented here on top of that diagram. And it's going to be making the life much easier to your operator. It's like a simple SCADA where you can combine measurement from any source, any sensor, any technology with the result of your water network modeling to show directly the main information to your operator. That is the last thing I was wanting to show you before just giving you some conclusion on the next step where you can go from it. The code of how to make the request to the web API from Excel is in this example that I have here. I can share that example to you. Maybe to the people of Swan, I will send that this Excel. I now realize that the Excel was not sent before. Anyway, you can write me or write the people from Swan. I will share this file with you so that you can have access to the code exactly how it was developed. You can write me at any time. If you start creating your first macro and you don't know how to proceed, feel free to write. We prepare this only for 1 hour. In 1 hour, we cannot move the world, but I'm going to be very happy of having questions from you and answering those questions from you. And more than that, I will be sharing with you some ideas of what to do next regarding the creation of a simple hydraulic network model with the account that I have been sharing with you, or you can create your own account in the system. So here, if I sign out, you can click on sign up, create your own account, and I propose you to do it and to run a first hydraulic level model based on an example on a workshop that I'm going to be sharing with you right now, the details of that workshop. So this website, Working Online, is a website also developed by us, where we have been putting several courses online. One of those courses is Smarter Water Distribution System Analysis. You can click on it, and we have been disclosing one workshop for all the people attending to this webinar. So it means first workshop, you just don't look to the other elements, just go to workshop 1, creating and running a simple hydraulic model. Click here, workshop 1, introduction, and point 0, workshop introduction. You can read that introduction, click next, and here all the elements related to workshop 1 are free for the people participating in this webinar. It means you can follow here. I'm proposing a very simple network that you can follow here. I'm going to be clicking here. Here is the layout of the network. All the data related to that network model is available. You can follow it to create a model in EPNet if you want, but I would recommend you to make a try to create an account here, to make your model online, to share it with me. If you want, I would love to take a look to what you're doing and write me at any time to know about your advances or any question that you could have related to the model. I will share my email here in a minute. So here is my email address. You can write me at any time, share with me your advances, or make any further question, either from creating hydraulic models or from the programming part using macros in Excel. I'm going to be very happy to answer those questions. And now we have 7 more minutes that I wanted to leave at the end, just for any question. Oh, I see that someone raised their hand. So I don't know, Moyo, are you moderating now? For the people that have been, I don't know who raised their hands.
Yeah, anyone who's raising their hand, Moyo, feel free to.
I didn't realize about it.
Ask your question. Yeah, go for it, guys.
Awesome. Thanks for the presentation, Idel. So basically, the system is suited for collecting data offline, like on Excel, and then sending to a central point.
Yes. That is, this is one of the main ideas of the system, that you can collect all those data, that you can develop your own way to collect all those data, no matter the format, no matter the provider, just by using the web API. You can put all the data in one single place. Yes. And once you have that, of course, the idea is to combine all that data and to use all that data combined with the hydraulic model you create. You create the hydraulic model, you and your colleagues in the system, then you push the data you have available from your network. No matter if you are reading it from a data logger or from someone else, you can push all that data using the web API in there, or you can manually introduce it in the system. That is another possibility that you have. So as a user, I will enter in a minute here. As a user, you can also go and manually introduce the data in the system. So if you go to monitoring, data channels, you're going to see the data channel you have available, configuration, edit the data source. And here you have flow sensors directly. I click on the sensor, measurement. Here you see the measurement available for that sensor, and you can add new values manually. So I will add a 10 here manually, but it is much more comfortable when you have an Excel received from a data logger. You create your own tool and you push automatically it with the macro. Very simple to do. And using the sample, I will be providing you the code. I will be providing you. You can follow that code and create something for yourself or for your company. And if you have any doubt about something, about how to proceed, just write an email, and I'm going to be happy to answer you or helping you on building that.
Okay, thanks for that. There's a question from Johan.
A question from?
Johan, if you're there, feel free to unmute yourself. If not, we can read it. Has this system been used by any water company?
Yes, I can show you some of the, so I think I can show you some pilot. I need to enter with my user. Okay. I will show you some, for example, this one. And I will be showing you, for example, this one. As is something very simple that have been built for the company. So I cannot show you all the, I cannot show you any project. So it is, water companies are very strict with the data they share. It is in Colombia, and it's a very small town in Colombia where the hydraulic network model is built. So it is a relatively small hydraulic network model. It was in combination with a water company in there, but also part of the PhD. The water network is very small. That's why it's not a problem to share it. But I have other networks that are much bigger. That, of course, we have a non-disclosure agreement where we cannot be showing that. But if you want to make a try, we are going to be happy to support you. We have been doing pilot projects with several companies, most of them small companies, but also bigger companies. And we are always very open to give a try of creating a pilot project with companies.
All right, any final questions before we close out? We have time for one last one. Any curious minds in the audience?
Hello, hi, this is Lu from Acom. Thank you for presenting this, and this is a great tool. I have a question here. So the hydraulic engine is EPA net, right? And the GS interface is OpenStreetMap. Is that a open source GS?
Yes. There are two answers in there. So we are using OpenStreetMap at the background, but on top of OpenStreetMap, we created ourselves a layer where we handle all the visualization from our network. For example, all these people here are not in a GIS engine. We have been developing that. And regarding EPNet, we are not running exactly EPNet. We have been rebuilding EPNet to make it easier, or to make it more adjusted to run in the cloud. EPNet was developed for desktop, but not for running in a scalable way in a cluster in the cloud. And we have been changing that. But additionally, I should say, if I go to analysis here and I want to run simulation, there are several options here. One of the options is actually even a transient analysis option. It's also available there. Quality simulation additional. So we have been developing independently of EPNet some other simulators that are also available.
Got it. And so if this map is cloud-based, which cloud service are you using? Like Amazon, AWS, or?
Sorry?
So which cloud service are you guys using? Is that like Google Cloud or Amazon?
And the provider, no, we are using Azure, Microsoft Azure. It's not the most trendy, but we had money for Microsoft, so they bought us, and they were giving us some money for developing at the very beginning of the company, and that's why we have most of our technology developing on that. So the back end is written in C#, running on a cluster, and then the front end is Angular. Front end is Angular, and the back end is running in C# in a Kubernetes cluster, using container. So our solution is container-based. So if you want to run it in your own server, we just give you a container image and you can run it on your side too. But basically, we are running the container into the cluster in Microsoft Azure.
Okay, so in terms of using this app, does the user pay like by minute or annually? Like how the license fee look like? It
depends on the utility. We normally get an agreement with the utility depending on the use they're going to make. We charge normally per user, but depending on the amount of calculation and the amount of measurement they want to be moving, we can make an agreement on use pay as use. So use based.
Okay. Yeah. Thank you.
But it's individually for each company. So we normally make an agreement individually depending on the use they wanted.
Got it. Thank you.
Sandy, you are mute.
Should jump in and cut you off. We're at the top of the hour. I just wanted to say thank you again, Idel, so much for joining us. Everyone give Idel a round of applause. And just really quick, we'd love to know what you guys think. So if you can just take a minute to fill out this survey, and also to register for our event coming up on October 19th. We'd love to see you all there. Thank you all so much for joining us today. It was really great. Thanks again, Idel, and have a great afternoon, everyone.
Thank you all for being here, and I'm going to be there for any questions you have and get back to me at any time. Thank you.